Hello, biology. This is day 6 of no school. Miss you guys a lot. Uh, yeah, quiet. Classroom's really quiet. So today we're talking about 18.3, which is all about energy and energy transfer. One of the 7 things that all organisms need to be alive is they need to be able to use energy. They have to use energy to carry out their essential functions. Energy is used to grow. The organisms use it to move, to maintain their internal systems, and to reproduce. 99% of the energy on Earth comes from the sun. The amount of energy that is transferred from organism to organism affects an ecosystem structure. Producers. Producer is an autotroph that captures energy and uses it to make organic molecules. Remember, organic molecules contain carbon. Specifically, the one we've talked about the most is glucose. Most producers use photosynthesis, like the ones on the top there, for solar energy. But there are some that use chemosynthesis, which is energy stored in inorganic molecules to produce carbohydrates. On the bottom picture there, I have some deep ocean vents that have a lot of energy in them that microscopic algae and bacteria can use. There's no sunlight down here in these deep parts of the ocean. This light that's here is from a submersible. So normally there's no light that even gets down here. So these guys can't use photosynthesis. They can't get that light energy. Measuring productivity. Gross primary productivity. Gross is not disgusting. It means total primary productivity. This is the rate at which producers in an ecosystem capture the energy of sunlight by producing organic compounds. So how quickly can they make glucose from sunlight? Biomass. This is organic material that has been created in an ecosystem. Producers add biomass by making organic material. These trees on the picture on the right there that are all chopped down, this is an example of a large amount of biomass. Net primary productivity. This is the rate at which biomass accumulates. So this is equal to the amount that's produced minus the rate of respiration. So even plants use cellular respiration. They burn some glucose. So how much is produced versus how much is used. That's your net primary productivity. There's 3 factors that affect this. And there's light, temperature, and precipitation. And if you increase any one of these, increase in temperature, or increase in precipitation, you usually get more productivity. You get more glucose being made. Plants do better when they get more light, when they get more water, when they have a higher temperature, to an extent. Consumers. These obtain energy by consuming organic molecules made by other organisms. They don't make their own. We call these animals heterotrophs. They produce food, consumers consume food. There's several different types of consumers. There's herbivores, which eat only producers, so plants. They only eat plants. There's carnivores, which only eat other consumers, so other animals. And then there's omnivores, and these eat both producers and consumers. So I have in order here, a koala is a producer. He only eats eucalyptus. And the tiger there, he's a carnivore. He only eats other animals. And then the bear, he is an omnivore. He can eat both fish and berries. He can eat both producers and consumers. Some more examples of consumers. You have detritivores. These are consumers that feed on the garbage of an ecosystem. So they're feeding on organic material, but it's dead organic material. This garbage is called detritus, and it can include dead organisms, fallen leaves, and animal wastes. Decomposers. These are bacteria and fungi that cause decay by breaking down large molecules into simple ones. They return these nutrients back to the soil, making sure that producers can then use it and start the process all over again. Energy flow. When an organism eats another one, molecules are metabolized and the energy is transferred. In this way, energy flows through an ecosystem. Trophic level. This is an organism's position in a sequence of energy transfers. All energy comes from producers, this bottom layer. They are the first trophic layer. And then as energy flows upward, it's eaten by herbivores. These are the second trophic level. As those guys are eaten, that's the third trophic level. And then as those guys are eaten, it goes up to the 4th trophic level. We usually don't see anything higher than 3 or 4 trophic levels. And we're going to talk about why in a couple slides. Food chains and food webs. Food chain. This is a single pathway of feeding relationships. So energy comes from the sun to the producer, to the herbivore, to the carnivore, and then back to the decomposer, or the detritivore here. Versus a food web, where it's an interrelated food chain. So it's more than one food chain. So starting with this shrub, it might get eaten by a rabbit, which then could get eaten by a mountain lion, or this shrub could get eaten by a grasshopper, which might get eaten by this shrew, which would get eaten by a hawk. The same energy is going through different pathways, so it's a food web, not just a food chain. Energy transfer. As an organism eats one another, not all the energy is transferred. On average, only about 10% of energy is absorbed. So plants absorb about 10% of the sunlight that's available, and then things that eat the plants get about 10% of that energy, and then things that eat those primary consumers get 10%, and then 10% again. So some of this is lost by animals in these lower levels, producers, consumers. Not all of them get eaten. Some of them die of natural causes, so that energy gets lost and goes back into the soil. Some energy is lost as heat. Even when an animal eats just one animal, he doesn't get all the energy out of it. Some of it's lost as heat, some of it's lost in catching the animal, some of it's lost in digesting the animal. There's a lot of ways that energy is lost in these systems. Limitations to trophic levels. Because so much energy is lost by the time you reach the top of the food chain, there are a lot less predator than producers. There's a lot less herbivores than producers. In this triangle here, you start out with 10,000 freshwater shrimp. Well, that can only support 100 perch. And those 100 perch can only support 10 northern pike. And that 10 northern pike can only support 1 osprey. So there's only 1 predator at the top of this food chain, but there's 10,000 of these little shrimp. So there's some very big limitations. You have to have enough energy to support your high-end predators. So, section 18.3 review. It's on page 369, questions 1 through 6. If you give me, I will give you extra credit if you draw me a food chain or a food web of some of our local animals. Hope you guys are having a marvelous Thursday. One more day till spring break. Miss you all. Hope you're doing well.